Hi, this is Kishore and welcome back to Kishorelytics. In this tutorial, we are going to learn something about the scikit-learn and the basics of the ML model. So in this tutorial, we are going to learn about two important models, that is called the linear regression and the random forest regression. So I don't want to take much time off you guys. Let's dive into it. Yes guys, in today's video we are going to learn something exciting and we are going to build some mini projects in the scikit-learn. So let's dive into it. So the today's main agenda is all about the learning something about the machine learning topics. We have put the base foundation of the machine learning, right? So machine learning. The today's agenda is all about the machine learning topic, right? So what is meant with the machine learning? So the machine can learn the data and can be predicts the data based on the previous data, and it can be predicted with the new data. When we give the data, like I'm just scrolling, it can predict the data, predict the future. Likewise, you can able to say it can gain the experience. It can train with an experience with the previous large amount of the data. It can, like for the example, the ChatGPT is also the machine learning. Likewise, there are many. It uses the reinforcement learning. So the machine learning can be classified into supervised learning, supervised, unsupervised, and the semi-supervised. They can able to say also reinforcement learning. So let me write it here. Reinforcement learning, right? So that can be, it can able to train, it can gain the experience from the large amount of the data. It can gain experience from the large amount of the data and can predict the next data. If we give the new data, means it can predict, it can make the experience, right? It can train with large amount of the data, so that can be predict with the data. So that's what happening in the machine learning. So in our today's agenda, let's discuss about the supervised learning. Later we will discuss something about the letter. So in the later sessions we have discussed, right? So the supervised learning. Supervised learning. The supervised learning, it can be categorized into two types, right? So the first type is called the regression, and the second type is all about the classification. So the regression is nothing but it is discrete values. It is that can be able to say it can predicting the house price. Today we are going to do in this mini project. We are going to discuss predicting the house price. We are going to discuss. So likewise, for example, I'm just telling predicting the house price, predicting the delivery time. Likewise, also we are going to do predicting the delivery time of the food. Likewise, the regression also, these are the examples of the regressions. So for the classifications, it's like the continuous values, like 0 it means cat, 1 is nothing but the dog. Likewise, it has only two values, like cat, dog, like food, pizza, burger. Likewise, we are going to predict. Likewise, it is known as the classifications. So that's what about the supervised learning. So now let's start with by implementing the projects. So let's dive into it. Yes. So let me get into my Jupyter notebook. So I just already downloaded the Kaggle dataset. If you want this dataset, please let me know in this command below. And all this dataset, all these resources are available in my GitHub repository, and the link to this GitHub repository are available in my description box. Just feel free to use this repository. And if you have any doubts about the machine learning, and you have any doubts anything, if you have any feedbacks, means also just let me know in the comment below. I'm happy to accept and I'm happy to express all those things. So let's get into it. I just already downloaded this dataset. So the dataset is nothing but the outprice.csv, and this dataset is available in my description box, and the link to this Kaggle dataset also are available in my description box. Just feel free to use. So I'm just using import pandas as PD. We are working with the data frame, right? Already we have completed the pandas, numpy, matplotlib, seaborn. All these 4 tutorials are available. So just look at my Kishorelytics YouTube channel. So and these videos are also available in my description box. Just feel free to use. So import, I'm just importing the pandas as PD. I'm just importing the numpy. I'm just importing the matplotlib. I'm just importing the seaborn as the SNS. So okay, fine. How to read the CSV file? Right? So we are using the CSV file, right? So df is equal to pd.read CSV. It can be available in the pandas, right? pd.read CSV of. I'm just writing the house prices.csv. So that's all. So the data frame. This is a data frame that is available. Okay. So that's all about this data frame, and we are reading. So let me run this again. So I just read out this data set. So it is reading. So just for a minute, it will be load. It has a 1,87,581 number of rows it has been having. So that's why it's taking time. So it is loaded. So the data frame is loaded. The data is loaded from the CSV file. So again, so let me know the shape of this data. So how it can be possible, right? So the shape of the data. These are the topics are available in my EDA. These are the EDA part. So let me get into this. These are called the EDA part. So wait a minute, guys. These are called the EDA part, right? EDA is nothing but the exploratory data analysis. Data analysis. Right. So in this exploratory data analysis, we want to see something about the shape of the data. We want to see about the information about the data. Let's discuss about this pandas tutorial. In the pandas tutorial, we have already discussed about these things. So in the exploratory data analysis, we are going to discuss something. So we want to find the value counts. Value counts is nothing but how much the data is distributed along the cells, right? So that's what the value counts appears here. And we have a lot of things to explore. We have first of all, let's analyze the data. Later we will build the model. So the first step is nothing but that we want to analyze the data. Analyze the data is possible only by the you doing the EDA part. So we want to the first step is nothing but the EDA, right? So the second step is nothing but that we want to split the data, train test split. Let's discuss about these things later. So again, the third step is nothing but the, let me write down here. So the third step is nothing but the model building. So the third step is nothing but the, after splitting the data, the third step is nothing but the column transformer, standard scale transformer. Let's discuss about these things in upcoming sessions. So the fourth step is nothing but the building the pipeline or building the model. So that's what we are going to do in this mini project. So this is a mini project, guys. Don't worry about this, all those things. So later we will discuss about the scikit-learn later in our latest tutorial, later tutorials. So as of now, let's build something great. So now what I'm gonna do that. So let me get into my Jupyter notebook. So I just want to see the shape of the shape of the data is nothing but the df dot shape. So if we give the df dot shape means this is going to be the output 1,87,531 rows, and there are 21 columns are available in the dataset. So this and this dataset link to the datasets are available in the description box. Just feel free to use, and you can able to put this project in your resume also. It's completely open source. So again, I just want to see the first 5 rows, right? So how is it possible? It is possible, right? df.ed. So it is df.ed. So just me put this df.ed command. So let me run this means I just get this output as the first 5 rows. So the rows are this mean the index, title, description, amount. What are the amount and the price? What are the prices available for 1 square feet? So location, the carpet area, status, floor, transaction, blah blah blah. There are 21 columns are available. So there are, and if you want to see the last 5 columns, df.tail is nothing but the df.tail. So what are the columns? We want to see what are the columns, right? So df.columns. Index, there are 21 columns: index, title, description, amount, price, location, carpet area, status, transaction, furnishing, facing, overlooking. So there are a lot of columns, right? So we don't want these columns. So we don't want the categorical columns. We just need the numerical columns, right? So that's why the model can predict the house prices. So the main agenda is all about the predicting the house prices. So that's what in this video we are going to discuss. So we want to drop some columns so that the model can train well. So that's what I'm just doing. Later we will discuss about this topic later. So the df.info. So let's discuss about this information. I just in the previous slide itself I just write it, right. So df.info functions. Let me put it down. So if you want to find how many null values, just these are the basic steps. These are the basic EDA process, right? So df.is null function dot sum function. So if you put this means how many null values are available. Null values are available in the columns. Let's discuss. So now it is the main part. So we want to eliminate the null column. Most null columns we want to eliminate. That's why we want to eliminate the most null column means because the model trained with the noise. If you train with this noise means the model can perform with them. So this is also the one important concept that is called the overfitting. Overfitting. Overfitting means the model can perform well on the training data. Well on the training data, but it doesn't perform well. Does not perform well on testing data. Testing data. So this is the main important part. Overfitting. Overfitting is also an interview question also. Overfitting is nothing but the model perform well on the training data, but it doesn't perform well on the testing data. So before getting know about the training data and testing data, we want to know something about the training data and testing data. So consider this is my entire data set. I want to split this data set into two parts. One 80-20%, right? So 80-20% is nothing but the Pareto chart. Let's discuss Pareto chart later. So the main agenda is all about the train slash split, right? So train, test, split. So what does that it mean? So we want to split the data for the training purpose and we want to split the data for the testing purpose. So why we want to split the data means the model wants to train the data. We don't want to train entire data. So we want to train the data for the training purpose. We want to split the data for the training purpose. This is for the training purpose. So the model can train with this data, 80% of the data, and we can able to test this data with we can able to test the model with this 20% of the data. So that's what it comes here. So that's what it is known as the 80% and this is known as the 20%. This is training data. Training data and this is known as the testing data. So the model wants to learn, model wants to build, model wants to learn from this training data and we are going to test the model. We are going to predict the model using the testing data. That's what happens here. So the model will well performance on the training data. It is going to be well performing. It is completely well performing on the training data. But it doesn't performs on the testing data. So that's what in the overfitting. So the second point is nothing but the underfitting. So underfitting is nothing but the model cannot perform on the training data, cannot perform on the testing data, doesn't perform. So the model does not perform on training data also. Training data and doesn't perform on testing data. Does not perform on testing data. So that's what happens here. So this is also a very important training questions, interview questions. So just note it down, guys. So the overfitting is nothing but the model will perform on the training data, but it doesn't perform on the testing data. So let's detail discuss about the training data, the testing data. We will discuss. And underfitting is nothing but the model does not perform on the training data, and the model doesn't perform on the testing data. So it both it's also doesn't perform. So underfitting happens. So why we are let me get into my we are discussing this overfitting and discussing means we want to reduce the missing columns. We want to reduce the non-null values, right? So I'm just doing missing percentage. First let's find the percentage of the missing values. So missing percentage and df dot is null. I'm just multiplied by 100. So let me get this percentage. So I just make this into one data frame. So miss df is equal to pd data frame of missing columns. What are the columns? I'm just what are the columns are with null values. I'm just getting there. And again, after getting to know all those missing percentage. So this is gonna be happen. So let me print in the miss df means it is going missing columns. There are 18 lakh 75 columns. Missing percentage is 100%. The plot area is nothing entirely not null values. So we don't want this null values, right? So let me release it. Like this, it is having title index. There is no not null values. So we don't want to delete, right? So we want to delete greater than 70% of greater than 70% of missing values we want to delete, because why we want to delete greater than 70%? The model can overfit. The model can perform well on the training data and does not perform on the train testing data. So that's what we want to delete these columns, right? So I missing values is equal to miss df of, I'm just deleting this missing percentage greater than 70%. I'm just deleting. So I'm just deleting. So now I just having the what are the columns are with I missing values. So what are the column means the plot area and the dimension, right? So we are going to delete this df dot drop using the drop command. I'm just letting df dot drop of columns is equal to I missing data. So I'm just deleted this. So now let me check with this df dot is null of some functions. So these are the columns I'm just having. So let's discuss about the categorical column and the numerical column. So categorical column is nothing but the strings, string column. So we want to delete these columns. So most of the time we don't want this column, but sometimes we want to take these columns. So let's me the categorize the columns, categorical columns and the numerical columns. I'm just selecting the object columns with the category columns. I'm just selecting the object integer columns and the again float column, float data type columns into the numerical columns. So after this doing all those things, I'm just printing what are the category columns and the numerical columns. So let me check with the price columns. So these are the price columns. So let me check with the amount column. So I'm just finding the messy data. So here I'm just seeing 42 lakh. This is going to be happen in the numerical column. So but it gives in amount in price as a category column. So we want to change it around, right? These are the EDA process. So carpet area, these also available in the category column, and the floor, these also available in the category column. But these are the numerical columns, right? So we want to convert this numerical column, convert this category column into the numerical column. So what I'm going to do that. So I'm just simply writing one functions in for the amount categories column. So def convert amount of values if pd.isNA of values return np.nan. So I'm just if the null value means I'm just simply not null values. So I'm just reducing the space. Strip is what we can use of the strip means you can remove the unwanted space, right? So in the amount column, so if the values is in the CR values, we want to multiply it with the crore. So if the amount is elif, I'm just writing with the lakh column. If the amount is in the lakh, if I found this value with the lakh, so I'm just multiply this with the lakh, 1 lakh. So else I just need it in the non-null values. So I'm just using this function. I'm just convert this amount type functions. If I see this means, so this is the column 42 lakh. So 98 lakh. So likewise I'm just saying. So likewise I'm just converting this carpet column. So carpet column, what we can see in the carpet column, square feet, right? I don't want this square feet. So I'm just converting this square feet, right? So df dot carpet area, I'm just converting into string dot replace. I'm just replacing with empty space. So I'm just using the resist function, regular expression. So I'm just using the strip function also for removing the unwanted spaces. I'm just converting this into the numerical column. So that's what happens here. So if I see means 500 square feet, likewise we are able to see. So again, for the ground floor, first floor, I just out of how many floors we want to see, right? So for this floors, I'm just writing this simple function. The extract floor of values. If there is not null value means I just simply replace with non-null values. So I'm just converting everything into the lower function. So if in this data set itself, we can able to see if the basement is value means the basement is nothing but the underground, right? So we want to return it as a -1. If it is starts with ground means I just return it as a 0. So if it is this value if the word contains out of means I'm just converting the 0 out of how many total values, how many floors. So likewise I'm able to see the current floor and the total floor. So likewise I'm just able to convert this into the one data frame. I'm just converting this drop. I can't deleting the floor column. Again I'm just adding this current floor and the total floor. The current floor is nothing but the 16th floor out of 26th floor. So likewise I'm just able to get, right? So I'm just df dot columns. I'm just adding these columns into the main data frame. So now if I see this df dot seasonal of some if I see means an ordinal value means I can able to get this total number of values. So likewise these are the columns I'm having. So again I want to delete this column, right? So we want to predict the values. So how we can able to predict means x is equal to df dot drop of, so the main target column, the target column. So let me explain this. So now the main agenda comes here. We have completed the EDA part, right? So the EDA part is nothing but the step one. Step one we have completed. So now the EDA part is completed. So we want to split the data. So we want to split the data, right? So here we want to split the data. We want to split the data in types of two categories: X train, X test, Y train, and the Y test. We want to split. The Y is nothing but the output value, right? So X is nothing but the input value. So today we are going to split the data using this X train, X test, Y train, Y test. That's what likewise here the Y X is nothing but the everything, entire data set. So apart from the entire data set, apart from the Y, that is amount, we are going to predict the model, right? If you give the new data, if I have this 10 acre and I'm just having 2 bedrooms, if the model can, if I ask to the model range, the model can tell the amount, that is 42 lakh. So likewise it can be able to predict. So likewise the amount column is the target column, like, so that's why I'm just doing target is equal to amount in price. So I'm just dropping this column again. I just want the entire data set apart from the target column. So likewise I'm just dropping df drop of columns. Df the y column is nothing but the output column, so that is the target. So that's what it comes here. So now let's build the model, right? Yes guys, let's start building the model. So for this I'm just using the scikit-learn. So from sklearn.model selection, it is available in the model selection library. So I'm just importing a train test bit. We want to convert this. I'm just already tell, right? X train, X test, Y train, Y test, right? So using this, I'm just using the train text split of X comma Y. The text size is 0.2, means 20% of the data, and the random state is it is going to be pick up it's in the random state randomly. So that's what happens here. So X train and the text columns, these are the columns are available for the text train. So after doing all those things, we want to pre-process the data, right? So from the sklearn.preprocessing, import standard scaler. So I just want to convert this into standard scaler. Standard scaler is nothing but the we want to convert for the median. So let 1 minute guys. So we want to we are using the pre-processing standard scaler. Standard scaler. So it is using the standard, right? Is nothing but the standard deviation mean. So likewise it converts for the if I have the amount 42,000, if a model can able to predict more number of the values, right? We want to convert this into the mean value. So likewise the standard scaler can be able to do that, right? So that's what I'm just doing. From sklearn.preprocessing, import standard scaler. Scalar is equal to standard scaler. I'm just initializing. So I'm just converting this X train scale to a fit transform of X train. So I'm just putting the testing data also. Scalar dot transform of X test. So likewise I'm just doing all those things, and again I'm just doing all those why I'm doing I don't know. So let me delete this cell after. If you find this cell notebook, means you can able to get a full project. So that's what I'm just holding. So let me start building the model, right? So from sklearn.linear model, import linear regression. So we are going using the linear. We are now today we are using the linear regression and the random forest model for predicting the basic model. This is a mini project, right? For example, for predicting the house pricing itself, the main agenda, main model comes in the mind is linear regression. So let's discuss about the linear regression. Later we will build the model. So linear regression. So what is meaning the linear regression? So as the name itself suggests, is the type of the regression for regression. So we are going to predict some values. It is going to be the continuous values. So like this we have discussed in the previous itself. So what is meaning the linear regression, guys? So it tries to predict the best line, straight line in the among the data. It tries to predict the best straight line among the data. It tries to fit the data. It tries to predict the best fit to the data. The formula for this x is equal to mx plus b. It is the formula. So what I'm going to do that, if you for example guys, for example the steady time is nothing but the steady time. If my steady time, I'm just having this data set steady time and playing time and the pass or fail. Okay, it tries to fitting the data. It tries to find the best straight line. So likewise, my study time is 5 hours and the play time is 1 hour. So can I able to pass this data set? Can I able to pass in the exam? Yes, definitely I'm able to pass. If my study hours is 2 and my playing hours is 5, so definitely I will fail. So likewise, it is tries to predict. So for example, let's discuss in this project itself. Let us discuss for the house price, the bedroom and price. For the 2-bedroom, the price of the house is 4 lakh. Let me for assumption. So for the 5 bedrooms, the house of the price of the house is 6 lakh. Likewise, if we increase this means that graph also increases, right? It tries to predict the best straight line among the data. So that's what happens here, right? So let me convey into my Jupyter notebook. So I'm just using the from SQL and linear model import. I'm just importing the linear regression model. So LR is equal to linear regression. I'm just using the model. So LR dot fit of X train scale. I'm just fitting that model. Fitting the model. I'm just writing means these are the column. I just trained with the model. So now let's try and find the mean squared error. So from sklearn matrices import mean squared error and R2 square. So mean square error of y test. We are using the test. We are now predicting the data, right? So we want to use the predict data. Y test, y predict LR. So that's what happens here. It predicts something great. It's giving something the mean square value is nothing but the 51%. Likewise, it is giving. So likewise, it is giving. So again, we want to build a random forest regressor, right? So let's discuss about the random forest. So now here itself I'm discuss. So now the second model we are using is nothing but the random forest. Random forest regressor. So random forest is nothing but the if you random forest means what comes in the mind means the decision trees. Decision trees is nothing but the if else part. So it is comes under the ensemble learning. So let's discuss about something about the ensemble learning. Later we will discuss about the random forest. So what is meant by the ensemble learning means? So here itself I'm discussing ensemble learning. What is meaning by the ensemble learning means building the multiple models, building the some combining. So the main thing, building smaller models that we can able to get the larger model, right? We can able to get the larger model. So the types of the ensembling is nothing but the combining the larger models, combining the smaller models, right? So these are the one model, these are the one model. We are going to combine into a single model. So it has a powerful model, combining the smaller models into the larger model. That's what available at there. That's what the meaning of that's what the definition of the ensemble learning, right? So the first model, the types of the ensemble is nothing but the bagging. So the second model is nothing but the boosting. Second types. So third thing is nothing but the stacking. Let's discuss detailedly. This is a entire part. This is a big theory part. Let's discuss in the another video. So as of now, we are using the random forest. It comes under the random boosting method, right? It is used to combine multiple models. It can predict multiple nodes, right? In the decision tree itself, it can predict the if either if it is raining outside, yes or no. So likewise, it is if else statement. It is a if else statement. It is predicting multiple nodes, right? That's what happens here. So later we will discuss ensemble learning later. So as of now, let's predict this model, right? So now let's get into my Jupyter notebook. As of now, I'm just importing from sklearn. I'm just importing from Ensemble. I'm just importing the random forest regressor. So the random forest is available for also for the classification. So that's what I'm just importing the random forest regressor. So RF is equal to random forest regressor. N estimator is equal to 100. Max depth is equal to 15. So likewise, we want to give the number of max depth and minimum leaves, and likewise also I'm just giving. So these are things I'm just using. I'm just fitting this model. RF dot fit of, and so now the model is trained. So let me predict this score means it will giving the it is perform well on 60 to 62% is giving, right? It is perform well. So from SQL and dot matrices import a mean square error. I'm just importing the R2 score. So likewise I'm just importing and predicting the model. So while predicting the model, I'm just using the y test. I'm just using the predicting score. I'm just finding the R2 score and I'm just finding the root mean square value. So later we will discuss about the root mean square value, what is mean the loss functions, what is mean by everything about the loss functions, chain propagation, everything in deep learning, everything in the later videos we will discuss. As of now, we will build the model, right? So finally, we have the one mini project in our hand. So later we will discuss a lot of things we will discuss in this video, right? So we will discuss about the what is mean in the machine learning and the types of the machine learning we will discuss, and what is mean in the supervised learning we will discuss, and we will discuss what are the EDA part we have done, we have discussed, and we have discussed about the overfitting and the underfitting, and we have discussed about the train test split, how to split the data we will discuss. So we will discuss about the ensemble model also. We will discuss about the standard scalar also. Likewise, we will discuss about the linear regression and we will discuss about random forest. As of now, the video has been ended. As of now, the video has been ended, right? So let me come with the next Tuesday. Until this is Kishore signing up from the Kishorelytics channel. Tata, bye bye.